Hi there and welcome from Ventura, California to today's webinar, Part 107 Rule, Impact on Key Application Segments in the Commercial Drone Market, sponsored by Inside Unmanned Systems and Microdrones and hosted by WebAttract, the leader in thought leadership webinars. I'm Lori Dearman, Senior Webinar Producer with WebAttract, and I'll be one of your moderators for today's session. And in just a moment, we'll be introducing our panel of thought leaders as today's webinar is about hearing from these experts as they discuss the implications of the FAA Part 107 rule on UAS mapping, surveying, and inspection applications. You'll also have an opportunity to have your questions answered at midpoint and at the end of today's presentation during the Ask the Expert section. Now, we've invited you, along with over 400 professionals registered from 36 countries, 35 states and provinces, representing a variety of industries. And over the next 90 minutes, regardless of your industry segment or location, we're confident that you'll find today's webinar of value. Now, before we get started, Richard Fisher, publisher of Inside Unmanned Systems and Inside GNSS, would like to take a moment to welcome you and introduce the co-sponsors for today, Mike Dziak, as well as Demos Gebre-Egziabher, who will be moderating the main portion of today's event. So over to you, Richard.
Thanks, Lori. On behalf of the Inside Unmanned Systems and Inside GNSS team, I want to extend a warm welcome to our international audience for today's web seminar. We're delighted you all could join us today. Our panel will be discussing the implications and impacts of FAR 7, and we've got a great ensemble of perspectives on our panel. In a short time, they'll take us from our new regulatory reality to the very practical with best practices and suggestions you can apply today. And now I'd like to introduce our sponsor, Mike Dziak of Microdrones. Mike?
Hi, thank you, Richard, and welcome everyone. This is Mike Dziak. I'm the Marketing Director for Microdrones. We offer rugged commercial drones and we integrate those drones with systems and sensors, primarily for professional mapping, precision agriculture, and inspection tasks. We're excited to be a part of this webinar and certainly this industry. It's a great time to be in this industry. There's no shortage of good news in the recent weeks, and that should help us all to be more successful. And that's really the purpose of this webinar. We're excited about our partnership with Inside Unmanned Systems. They've pulled together a great team of subject matter experts who are going to help inspire us and inform us. So with that, I'd like to thank you all once again for joining, and to turn it back over to those experts, starting with Richard from Inside Unmanned Systems. Richard?
Thanks, Mike. Now I'd like to turn the webinar over to today's moderator, Demos Gebre-Egziabher. Over the years, Demos has helped develop and moderate numerous Inside Unmanned Systems and Inside GNSS webinars, and he's especially close to today's topic. Demos is an associate professor of aerospace engineering and mechanics at the University of Minnesota's campus. Recently, his work is focused on multi-sensor solutions for operations in GNSS stressed and GNSS denied environments, including the use of such systems on unmanned vehicles. Demos, thanks so much for joining us today.
Thank you very much, Richard, for that introduction, and welcome everyone. We're glad you could join us today for this webinar. Before we get going, we'd like to do a quick poll to get a pulse of the audience. So, Lori, if you could pull up the first poll question, please.
Absolutely. Coming up on your screen, you should see that question, and we'd like to know, I'm interested in small UAV application for, and feel free to select all that apply, aerial mapping and survey, precision agriculture, infrastructure, inspection, research and development, or other. And looks like we've got 69% aerial mapping and survey, 34% precision agriculture, 52% infrastructure, inspection, 38% research and development, and 28% listing other. Demos, any thoughts there?
That's a nice spread of potential users, and I think everyone is going to get something really useful out of today's webinar. So let's go ahead and introduce our first panelist for today's webinar. So our first panelist is General Jim Poss, who is the CEO of ISR Ideas, an intelligence, unmanned aerial systems, and cyber warfare consulting firm. He's the founder and former executive director of the Alliance System Safety of UAS through Research Excellence, SURE, the FAA Center of Excellence for Unmanned Research. He's a 30-year U.S. Air Force veteran with combat experience in 4 wars and was the Air Force's senior career intelligence officer at the time of his transition from active service in March 2013. He's a leading expert on UAS, having helped design the U.S. Air Force Remote Split Operation System for U.S. control and the Distributed Common Ground Station for UAS intelligence analysis. General Poss has also extensive experience in cyber operations from his assignment with the National Security Agency and as the Air Force lead for stand-up of U.S. Cyber Command. He is the 2012 winner of the Aviation Week's Curtis Sword Award for his leadership in Anglo-American aerospace relations. With that, I'll hand it over to you, General Poss.
All right, well, thank you, Demos, for their very kind introduction there. Okay, well, I tell you what, I really struggled with the title of this briefing. Originally, I was going to call it Dawn of the Commercial Drone Age with a couple of exclamation points, and then I got thinking about it. And I finally went with a question mark. I did it with a great amount of thought, and the reason that I put a question mark in there is that we've got a couple areas that we've got to work hand in hand with the FAA before we really enable this market. And let me first go through the basics of Part 107 and why I say that we're so close to really enabling a commercial drone renaissance in this country. Okay. All right, so the basics. Part 107's been out for a few weeks now, and the basics of it are you need a remote pilot certificate to fly. Not a huge surprise to us. If you were following the drama behind 107, you generally saw there were 2 schools of thought. The manned aircraft crowd wanted to have intensive training and demonstrated flight proficiency in the aircraft that you're going to fly, just like we do for manned aircraft. The folks that were generally, from the Silicon Valley kind of folks, wanted to have a much reduced requirement for that, where we just had to do computer-based training. What we got was something in the middle, to where you do have to take computer-based training. However, you got to take the test at an FAA testing center, and you do have to get a TSA background check. Next one's not surprising. You have to register your UAS. We've had to do that since November of last year. You're not technically registering your UAS. You're registering as a UAS remote pilot, and then you can have multiple UAS underneath your registration number. The one that was debated quite a bit, and the FAA erred on the side of caution there and did not put airworthiness standards for small UAS under 55 pounds. We'll get into that in a little more detail when we start talking about the new micro UAS rules that may be coming up, but generally, if you fly within the restrictions of Part 107, you don't need airworthiness certificates. We are restricted to line-of-sight operations, but at least we don't have to have a visual observer like we did under the old rules. And we'll talk a lot more about line-of-sight later. UAVs must be under 55 pounds or smaller. I occasionally get a lot of questions about why 55 pounds. Believe it or not, the answer is that was the weight limit that was decided for model aircraft, and the FAA's kind of stuck with that, so there's no real research behind that 55-pound weight. That's not a magical limit. That's not going to hurt you if it falls on your head, obviously. And because of that, Part 107 says that you can't do operations over people not directly involved in UAS operations in the open. Now, the cool part of this is the in the open part. Before, you just flat out couldn't fly over people not directly involved. Now you can if they're under some type of cover underneath a roof in a vehicle. And the FAA is also aggressively working how to loosen up that rule quite a bit. This one was a little bit of a surprise. We thought it was going to be above 500 foot above ground level. It's restricted to 400 feet. But it's got an interesting exception there. You are allowed to go over 400 feet AGL if you stay within 400 foot of a structure. So, for example, if you're inspecting a 500-foot tall cell phone tower, you can fly all the way up to 500 feet. And keep in mind, it's only fairly recently that it's become crystal clear in the eyes of the court that the FAA could regulate below 500 feet. We've never really regulated before that. The FAA has always said they can do it. And we did have a landmark court case last year that reinforced the FAA's authority to do that. We also can't fly over 87 knots. You can only fly during day, dusk, dawn visual flight rules with 3 nautical mile visibility, so you got to have good visual flight rules weather. Here's a good one that we really appreciated in Assure, and I know the aviation insurance industry appreciates. You have to report serious injuries or property damage other than to the UAS itself of at least $500. That's been one of the more frustrating aspects of trying to do safety for UASs. There just isn't any reportable data like there obviously is for manned aircraft. Now the last one I didn't get too excited about until I read it about 3 times. We're now allowed to operate in Class G airspace without ATC permission. And I didn't get too excited about that to begin with because, as you know, Class G airspace, and let me go to the next slide here. Class G airspace is kind of the none of the above airspace. So, Class B is for major airports, Class C is for not so major airports, and Class G is kind of everything else in between it that isn't Class A, which is above 18,000 feet, or Class E, which is kind of 700 to 1,800. The cool part is previously you were restricted from flying within 5 nautical miles of an airport unless you talk to the tower. That restriction is removed, and so this means as long as you fly within 107, stay within Class G, you don't have to let that small non-towered aircraft that happens to be within 5 miles of your backyard know that you're going to be flying it. And correct me if I'm wrong, that's about 90% of the everything that classifies as an airport in this country. So that's absolutely fantastic. But all in all, I'm going to go with this is boring, expected, predictable, foreseeable, typical FAA, except for one section. And here's the key section. You can request a waiver of most operational restrictions if you can show that your proposed operation can be conducted safely under a waiver. Ladies and gentlemen, that is huge. I'm going to stop right now and turn it back over to demos so we can turn it over to a couple of our Canadian friends who are going to tell us what they've been in Canada under very similar rules to Part 107, and it'll show you the great things they've been doing. I'll come on later and talk about the big 2 restrictions that we need to work on first before we can take out that question mark behind dawn of the commercial drone age and put in an exclamation point, and that's how to get around the restrictions on line of sight operations and operations over people. So Demos, I'm going to turn it back over to you.
Thank you, General Post, and we're looking forward to the second half of your presentation. Now let me introduce our second panelist, and that is Mike Hogan. Mike Hogan is a Microdrones Business Development Manager in charge of identifying new business opportunities and helping clients to be more successful. Prior to serving Microdrone customers, Mike Hogan served in the Royal Canadian Air Force for 21 years as an intelligence officer, a geomatics officer, and as an airfield engineer. He earned his master's in engineering from the University of New Brunswick and his bachelor's in engineering from the Royal Military College of Canada. With that, I'm going to hand it over to you, Mike.
Thank you very much, Demos, for the introduction. And what I'd like to do is go through a few different points based on my experience over the past few years of working in this industry. Whether you're a service provider with UAVs, or you want to get into starting, being a service provider, whether you want to be a reseller of UAVs or drones, or you want to use the services of UAVs or drones, I think I have some points and some observations that might help you out. And we've learned a little bit about 107, but before we talk specifically about drones, I think I'd like to ask some other questions as I walk through it. So my presentation, my briefing, will walk you through my experience over the past few years and how we can learn from that. Typically, the questions that I get are very technical in nature. And what they talk about is how long things can fly, how much can it carry, what type of batteries, do you have this type of capability, that type of capability. And these are all really, really, really great questions. But what I like to do is start off a lot of the discussion is kind of maybe try to see what people want to do with their systems. Okay, so what I'm going to walk through is my process in that. To start off with, I usually talk to people want to get into the business is what are the barriers to this business. Up until Part 107 came out the past month or so, in the U.S. the regulations was a bit of a barrier. There was an exemption, the Section 333 that was there, that allowed people to actually get up and flying, but you had to be a pilot, or there was a lot of problems with that. Around the world, the regulations are coming out. We're starting to see it in Canada. They've been flying for a few years and doing that in Europe. We see the same things. So overall, the regulations are becoming less and less of a barrier, and they're starting to enable those operations to happen. I'm not saying it's finished yet because there's a lot of work to do, and I'm sure General Poss will go into that, but really it's less and less. The next part I would like to hit on with clients and potential operators of UAS is you're still conducting flight operations. Although these systems are made to be easily flown and operated by people, the thing is you still have to be very conscious about your operating in the airspace, and your airmanship, as we call it, or understanding how to operate there is very important. So this is another part, and what that means though, from people want to use it, is you need to maintain those skills and practice that as you go through from there. So that was one of the barriers. The biggest one that I see, and it's based upon my experience, is what we're going to do with all the data that's collected. As you can imagine, it doesn't matter which application, if you're dealing with mapping, precision agriculture, and some sort of industrial inspection, you're collecting some form of data, and you're going to have to process that data and have to have the expertise or the knowledge to be able to analyze it and provide an answer to a client. So it's something that I advise people on to consider as they're moving through it. And I think in the past year, the other one that I came up with in my learning and my experience is asking people, do they have an existing business or existing clientele that they can add to add drones to? Starting off a drone business without clients, won't get you too far. Okay, so buying a drone doesn't allow you to start printing money, I guess, is my response to clients. So the next part I go into, when people start talking about technical parts, I try to say to them, try to explain to me what specific problem you're trying to solve. If we can get through that, then we can start to look at how they currently do that, right? How they're currently doing that, and then how we can improve that process. And some of the examples, the easy one is the volume of a pile. We can look at, is there rust on this pipe? Is there a hot spot on that power line? These are the type of descriptions that I like people to explain to me what they're trying to do. And this helps in allowing the experts, whatever company you're working with, to provide a technical solution or technical recommendations for you. I use the example of my father, who's been a civil engineer for 50 years, taking people's requirements and turning those into things. And he said to me one day, Mike, I want to get some LiDAR data. I said, okay. He goes, well, what should I ask for in this post spacing? I want to do that. I said, listen, explain to the contractor that you're going to work with what you want to do with the data. If you want contours at a certain difference, or if you want, explain what you want to do, and that contractor, that person will come and explain to you the type of product that's there for you. So that's what I try to get out of people, is explain the requirements. And we continually hit this off with our sales staff, is trying to get those requirements out of them. One of the tools that I like to use in trying to describe this or walking through that workflow is something we work with called the DIKO Pyramid. So data, information, and knowledge, turning into kind of organizational decision making. So if you can imagine this pyramid, and I'll walk through an example on the next slide, what we're taking is we're taking this pyramid, which has a strong foundation or a big foundation of data. We're taking that data, we're transforming it into information, we're processing it, we're taking that information, we're allowing some expert or software or some has taken it, changed that into knowledge so that we can actually make recommendations to make a decision in some sort of process. So you can imagine that pyramid having a strong structure is important, and every level is important. And I'll walk you through a quick example to show this. So if you can imagine that the question flowing into this pyramid would be, what is the volume of that specific pile there, if you're working the gravel, whatever, or any kind of thing where there's volume calculations. So the first thing you need to do is you need to collect the data, collect the imagery. In this case, if you're not using LiDAR, you're going to collect that data, and you're going to have to transform it by processing it, that imagery, into what we would call ortho images or DEMs. So that kind of takes us through the first two levels. But those orthos or DEMs don't allow anyone to say that the volume is there. There still has to be a software and then someone processing those DEMs and looking at it to be able to say that the volume of that pile is this many cubic meters from there. And in the end, that your client or your future clients, that's really what they're interested in, is that answer. What you're interested in is making sure you have that strong pyramid in order to provide that answer from there. So this can be applied to any of the applications or any of the industries, either be precision agriculture, industrial inspection that you're working in this pyramid, so understanding that. And what I'd like to do is just talk quickly about some of the observations as we walk through that pyramid. That we all know that collecting data with small UAVs is actually easier than it ever was. This is, there's tons of different systems out there, different price points that you can use to collect it. The biggest challenge I see, and as we work with people, is actually the ability to collect quality data in order to make the base of your pyramid strong. And it's not just about quality, it's also about quantity, collecting the right amount of data and not too much data to do the job you need to do. The other observation I think that comes out, and it relates back to the barrier, the first barrier, the third barrier I talked about, is being able to transform that information into knowledge and then transfer that knowledge into an answer that someone can do it. That this requires some form of expert advice or experience in order to provide that. The data, as we go up this pyramid, typically goes from gigabytes or terabytes, depending on the area that you're collecting, and results back down into potentially a single kilobyte or a small text table answering that. And the other one I like is the building of the pyramid, understanding that if you have the strong foundation as you make your way up, that you'll have a strong pyramid. And this could also be referred to as garbage in or garbage out when you're working with data. And in the end, really the client probably doesn't really care about all those different steps. All they really care about is having a quality answer at the end of the day that will help them make a decision for whatever business or whatever kind of industry they're working in, be it that calculation of volume pile that they can report for their company, or it could be, do we change that power line because it's rusted out, or that tower, is it time to do some work on that tower? Those are the types of questions that need to be answered. I'd like to close and just kind of discuss about some key points, what I've seen for the small UAS industry, and what we can do in order to help sell to our clients, help sell to whoever we're going to work for in doing it, but to use this system. And I think part of it out there is, the biggest one is educating our clients, be it on what the rules are and how to use the UAVs, or be it on how that process works in order for them to provide quality results and understanding how to request those results from there. I go back to the example of my dad. I say, try and explain to us what you want to do. Don't try and tell us how to do that from there. We'll figure out how to do that. So educating our clients on how to properly request specific products will help us achieve this in the end. The other point that will help businesses out, I think, is remembering to find your niche that you can work in. If you have a niche that you're working in, or that you can work in, that you can build and get strong and build your experience, then you can build upon that and work your way out. If you're trying to say, I want to get into mapping, precision agriculture, inspection, I want to do some surveillance, that's very broad and separate kind of categories within the industry that require specific tool sets to do that thing. That's very difficult. I would suggest to focus on one of those applications and then move your way through that. The other part that's interesting when we talk about safety, and there's kind of a few aspects to the safety. Number one is operating safely, obviously within the airspace. This is key part to it, and important, but it's kind of secondary when we're trying to sell, or we're trying to use these systems to do professional work, is actually the safety benefit that's provided by using small UAS. So anytime we can keep people from climbing towers or vertical structures, anytime we can keep people off of busy construction sites or busy sites that they're doing processing of large material, this is a great reason in order to sell this capability to your potential client, and to show that it can do the job better than currently how they're doing it. The other part talks about flexibility, and it kind of relates back to your niche. What you should be looking at for your systems is an ability or a flexibility to add and change payloads. This is important because small UAS provides that. You could one day be doing mapping jobs, and if you have that part of the market, you could use that same system, maybe with a different payload, to do some inspection work on it. So small UAS actually allow you to that flexibility to do it, and to go potentially from one market to the other one as you're building your company. So flexibility and looking at systems from a flexibility perspective is also very important. Now, the other part, and it's one of the ones I like the best, is having access to your data. And I've talked about this in the past to people, is maybe your options before were having a surveyor go out onto your site, or someone walk around or drive on your site. The other option was to have an airplane to go and collect your data for it. Now we have this middle ground where small UAS are starting to fit in there, and you can actually collect the data, not based upon when they want to, or when it's advantageous to them. It's actually, you can do it when you want to do that. You can collect that data at the beginning of a job, halfway through the job, at the end of the job, or you can collect it every day of the job for you. So it actually have access to the data, your data, and most important, the answers to that data. And the final point that I'd like to hit on is cost. It's always a question that people ask to me, and what I say is the cost of the hardware of the systems is actually the smallest part of the cost of running or setting up your small UAS business. The biggest cost is going to go into looking at the other parts of the pyramid, and the other parts of is looking at the training of your people, the cost of the software to process things, and the continual maintenance of that capability of your entire flight operations is actually a greater cost that you're going to have to invest in, and the hardware costs are just a small percentage of it. And the other aspect of cost is actually how we're going to sell these answers to your clients. People are going to say, hey, listen, you can do this, they think it's easy for you to do that, so it has to be less expensive. I argue that the results that we're going to provide to our clients are going to be of better data quality and of better value to them, and of course, which comes with increased cost. So I wish you the best of luck in your continued endeavors in working in this industry, and I'd be happy to answer or continue these discussions with anyone out there. But at this time, I'd like to pass it back to Demos.
All right, thank you very much, Mike, for that presentation. So we're going to take a short Q&A right now, where you, our audience, get a chance to ask our panelists some questions. So, and please send in your questions as we're going along, because we do like to get questions from you. Some of you already have sent in questions, so let me pose this first one here. I think this one is for General Poss, and we've got a couple of them, and I'm going to bundle them up into one question. And the question basically is Part 333 obsolete now that Part 107 is here, or how will the FAA handle the remaining Part 333 exemptions that have been filed, and things related to that? Can you say something about that, General Poss?
Yeah, sure. That's a really great question, and the answer is when Part 107 came out, there were about 8,000 Section 333 exemptions that were still awaiting approval. So the FAA triaged those, and they put them into 3 packages. So the vast majority were those that were covered by Part 107. So those folks that had 333 waivers in got a nice email saying, congratulations, your 333 is no longer needed. You can fly under Part 107. The next group, which were quite a few, were those that looked like could be covered by a waiver, depending on what you had. So, for example, if you just wanted to fly to 500 feet instead of 400 feet, and it was in an open agricultural area, you'd probably get that one approved. But that was the only thing you were asking to fly outside of 107. However, there were, literally about 8 of them, and I didn't get details on what were in the 8, that are still going to have to request a 333 waiver. And those are ones that just are too complex to handle with single waivers. So, if you're going to ask to, and this is a bit of a stretch, but if you're going to ask to fly an unmanned cargo 737 in class airspace from, Memphis to Los Angeles, that's just too much to handle under the current waiver. So if you were a commercial vendor, you'd ask for a 333 waiver. If you're a public entity, you can still go for a COA, certificate of authorization, for that. Hopefully that answers the question.
Thank you, General Poss. Let's see, next question. This is for our panelists from Canada. And again, I'm paraphrasing the question is, the question really is, do you expect other countries like Canada to adopt FAA-like rules? And I think the more appropriate question would be is, what are the rules like in Canada right now for doing operations akin to Part 107? Mike, I'll pose that question to you.
Yeah, so right now I think they're very similar. I think the little subtle differences right now is the rules aren't official like they are under Part 107 in Canada, but effectively you're able to conduct those very similar operations, very similar criteria in Canada right now. Obviously there's a little bit difference of process because it's Transport Canada and not the FAA, but you can see the equivalence from there. And I think it's a question, matter of fact, the other part of it is what we will see is if countries haven't come up with it, I think they're going to adopt similar type rules to start with, at least with line of sight. And maybe Ben will have more to add from his side.
Ben, do you want to add a little bit to that?
Yeah, some of the main differences that we've noticed with Part 107 and Transport Canada's special flight operation certificates is you don't have to use a visual observer like General Poss hit on. That's going to be that's a key thing that we have to have a visual observer. We have to have a cameraman controlling the camera if you're having a camera sensor on your equipment in Canada. So with Part 107 not have be used, that's gonna make operations a bit smoother.
All right, so let's see, next question. This is going to be for General Poss, and it's about operations in Class G and Class E airspace. The question is, not all non-towered airports are in Class G, some are in Class E from the surface up. Can you explain how the UAS user can tell the difference, and anything more you could elaborate on those kind of potential operations?
Yeah, thanks. And, kind of like what I said in the remarks, I was a little bit surprised that they allowed operations in Class G without ATC clearance, removing the no operations within 5 nautical miles of an airfield without contacting them. Yeah, that's a tough one. And, generally, Class E and Class G airspace compete for, none of the above airspace. Class E should be marked on your aviation maps, and so you should know to do that. The question I'd have to ask, and we'd be good to ask the folks at AirMap and some of the folks that are talking about geofencing out there, whether they're capable of putting in the Class E versus G boundaries, because I agree with the guy that asked the question. It can be difficult to tell, the difference between E and G out there. But at least we're not having to call the tower if we're operating at an untowered airfield within 5 miles, because gosh, if you look at just about any populated area in the United States, and you start drawing 5 nautical mile circles around every airstrip out there, it gets A, very difficult to operate, and B, puts quite a load on the airspace managers for those smaller airfields, because they're constantly getting phone calls and emails and whatnot. So yeah, that can be a tough one. I feel your pain.
All right, thank you for that one. Let's see, next question here. I will pose this one for I guess both Mike and Ben, but I'll first give it to you, Ben. Now that Part 107 is here, are there applications that your customers are looking for that can't still be done under Part 107? I know we haven't talked about waivers to it, and we'll talk about that later on, but can you say something about operations that are being requested that can't be done under 107?
Yeah, absolutely, Demos. The biggest one that we've run into is that operating over people. A lot of our operations are utilities, and we're doing power lines, so distribution. A lot of distribution poles are running along a public road. Sidewalks are right below them oftentimes, so it's pretty difficult to run an operation where you got to run pretty much a rolling stop traffic service, where you got to shut down traffic, you got to shut down the public for about 20, 30 meters, and then just move along. So it can really clog up the system, and then sometimes ATC doesn't want to give us clearance for that. Transport Canada doesn't like that because you're shutting down roads and stuff. So I think that's going to be a key cog to remove to really open up Part 107 in the U.S. and Transport Canada in Canada.
All right. With that, I think we need to move on to the second half of the webinar here, but please keep the questions coming, and we have a second Q&A at the end where we'll ask these questions. So with that, let's move on, and to do that, there's a poll question up, second poll question. Lori, if you could bring it up.
Sure. We'd like to hear from you. With the clarity provided by Part 107, a compelling case can be made for UAS operations in, and go ahead and give us all that apply in your opinion: aerial mapping and survey, power line, pipeline inspection, precision agriculture, public safety, cargo delivery. All right, 81% aerial mapping and survey, 69% power line pipeline inspection, 63% precision agriculture, 52% public safety, and 19% cargo delivery. Demos?
Again, an interesting spread. It's going to be, the next presenter is going to talk about aerial mapping and survey, and the other ones you'll get to hear a little bit more later on when General Poss comes back and talks about what needs to change to allow some of these other operations. With that, let me introduce our next panelist. And our next panelist is Ben Van Laer, who is with Raycon Industries. He's an operation manager overseeing all aspects of their UAV division. He successfully wrote to UAV operations and safety policies for Raycon, granting them Part 333 section clearance under the FAA for United States operations, and Transport Canada special flight operations certificates in Canada. Specializing in utility and telecom inspections, he has helped Raycon grow to become the premier UAV service solution in the Pacific Northwest. Before being fully immersed in UAV technology and services, Ben was a student at Dalhousie University and Simon Fraser University before settling in Vancouver, Canada. With that, we'll hand it over to Ben, and he'll tell us about things that they're using UAVs for right now. Ben?
Thanks for the introduction, Demos. We're going to take the next few minutes just to share my experience over the last 2.5 years working with Raycon Industries and just our UAV operations, what we found successful, what we hope to share with you, how you can integrate it into your business plan, if you're wanting to become an operator, maybe some of the key points that can really help you grow with that. So we're just going to move right to this first slide here, this general UAV constraints. General Poss has hit on the top two real well. We can't operate beyond visual line of sight, can't be higher than 8. Weather impact, you need to know exactly what type of weather you're going to be operating in, because those can pose a great constraint on different types of equipment. With Part 107, we know that beyond visual line of sight is out of the question right now for most Part 107 users. So UAV battery life, a lot of the commercial users that we've run into, they're using LiPo batteries, not a lot of gas or combustible users of UAV equipment. So UAV battery life, you're really restricted to about 25, 45 minutes. So beyond visual line of sight, if we're going to go that route, battery equipment, battery life has got to improve quite a bit. So moving on here to the benefits. So these are the benefits that we tell clients. So when we got into the business, we went into a lot of different clients, and these are the benefits that we told them, and they were shock and awe. You go in and you tell them that no longer are you going to need a helicopter, or no longer are you going to need a bucket truck to visually access sites. You're going to be increasing safety to humans, to workers. You're not going to have to put them on high voltage power lines. You're not going to have to put them up a tall cell tower mast. These are all things that can really increase safety. Another one is it's going to decrease cost. The use of a helicopter to do an inspection is quite expensive. The use of bucket truck, that requires a lot of manpower, so your cost is going to go up. The use of a UAV, if you're going to just give one to your crews, if you need to go inspect a tower, you can just send it up real quick instead of having to climb the tower or the structure. If we go on down to the safe infrastructure maintenance management, this is one that we've run into a lot of with clients in the utility field. A lot of clients, they just can't keep up with quality control, quality management, safety standards that they want to do, and that might be due to the lack of manpower or the lack of budget. With the introduction of Part 107, I believe that UAV usage is going to really help clients, service industries keep up with that QC/QM, and they're really going to increase their safety. And I think that's just one thing that we have to look forward to. We like to say that better data collection. Mike really hit on that already. Another thing, in the Pacific Northwest, we're real green up here, so we like to tell everyone that UAV is a lot more environmentally friendly. Moving on here, we're just going to talk now about, we've talked about the benefits, but is there value in those benefits? Sometimes clients just say, okay, that's, sounds great, but what more can you really bring? So you got to find the value that UAS can bring to your specific clientele, or if you're trying to integrate it into your business, you got to figure out what type of value you can really bring. So the first bullet says specific operations require specific UAVs. We found that for our type of inspections, we're not going to be using fixed wing UAVs. We don't do precision agriculture at this time, so we use quad rotor UAVs because they can get around tight spaces and they can really improve inspection processes. So you got to find the right equipment for the type of job that you're going to be doing, and that goes right into that niche, finding your niche. What's your experience? Our experience, as I mentioned, is in the utility field, where I've got a lot of power line technician background, and so that plays right into, that's our expertise. We're not into film, we're not into tourism, we're breaking into oil and gas right now. So if you really want to legitimize your company or legitimize your service, it needs to really be based upon what you can do. We've heard horror stories. We've been out on demonstrations where we're doing a pilot project, and they say we've had a couple UAV service providers come out, provide a service for us, and their equipment got close to the cell tower frequency, or it got close to the EMF coming off the power pole, and it crashed right into the pole, or it crashed right into the line, and it shut down the power. And they, we didn't know, the client will say, well, they didn't know that, these frequencies were coming off these structures, and it shut down. It cost us a lot of money, and, we're really hesitant of using a UAV. So you got to know, you got to know exactly what your drone can do, and that comes with experience. One thing we always find too is clients don't know what they want, and so they'll ask, can your drone do this? Can it do that? So you need to be able to educate these clients, these industries, what UASs can do. It's very new to them. They think of it as limitless possibilities. Inspections that they relatively can't do, that are difficult to do, now they can do with the UAV, but sometimes that's not the case. So you need to understand what a drone can do. It might not be able to fly up a penstock or fly down a smokestack, but if you can help educate and improve that service part, your clients will just really, it'll really help take your business off, and you'll really legitimize your business. So getting there, this is a key part. So now we've told the client benefits, we've shown them the value. Now we want to get there, and we really want to continue to legitimize our company and legitimize the business. As a new user, you want to integrate Part 107 into their plan. So What's the key to do that? And I think the key right is that first bullet, and that's mission planning. This entails, knowing the type of location that you're going to be flying at, if it's urban, if it's rural, where's your closest airport, where's your hospital, having the right safety management plans, emergency management plans. This helps legitimize your operation, your services, and it really shows that your client that you're taking the initiative when you're marketing your services. So now, you've got the job. Now you're taking the route of, planning, because they're used to manned operations and they have manned ways of doing pre-job assessments. These are type of things that you need to integrate with UAS. Public education notification, another key thing. We do a lot of work through private property. Oftentimes we'll tell a property owner that we're going to be flying a UAV, doing an inspection on a tower or a power pole, and they're fine and great. It's awesome. Sometimes if you use the wrong word connotation, maybe you say drone. Sometimes they get whoa, you're going to be using a drone. Please get off my property. So you need to educate. You need to notify the public, because their understanding is starting to improve too, and especially Part 107, skies are going to be filled up with UAVs. We need to really continue that education. Understanding the operation, we've already kind of touched on that. Data management, Mike's hit on that real well. Better data. This is a key that Mike touched on really well, and I want to hit on that just a little bit more. I heard from a colleague that clients, they don't care about the drone, so they don't care about your equipment technically. They really just want good data. And we like to call this type of good data usable data. And that usable data, it can be, it can change from client to client. It can change from project to project. And oftentimes you'll find that clients know exactly what type of data they want, because, UAVs, like I said, they have limitless possibility of deliverables. So they don't know what they want. So if you can educate, again, different type of sensors, there's different type of deliverables that you can offer, maybe geo-reference, maybe 3D mapping, maybe assessments of photographs. These are the type of data that they want. They don't just want expensive photos. They just don't want a collage of photos of a tower. They want to know what those saying of that tower. So again, that goes back to your experience and finding your niche. So moving on to the next one here. Where do I personally see potential takeoff of Part 107 with the rules that are out there? And that's really in emergency hazard inspections. We've been contacted by certain authorities in the BC area of British Columbia to do fire monitoring. And what they want us to do is, for forest fires, they want us to fly up in the morning with thermal cameras and do a thermal map, and then give them that thermal map so they can give their manned aircraft the exact hot spots of where to go, their geo-reference for them. So if you can coordinate with your local authorities, Part 107 in the U.S. can be used right away for these type of inspections. Storm monitoring and response, it'd be great for post-disaster, post-tornado storms, down power lines, knowing when it's safe to put in the manned services to go in and do repairs, etc. Those are great Part 107 uses. Safety, rescue planning. We have a local search and rescue up in northern Vancouver that uses UAVs in their search and rescue. They hook up thermal cameras, send up their UAS to do monitoring for lost hikers. So those are just takeoffs right now, Part 107, that could be used today. The next couple slides are going to be some projects that our company has done that can be done right now today in the U.S. Some of these are done in Canada, and I believe one of them is done in the U.S. This one right here is a inspection of a 4.5 canal in eastern British Columbia. This canal was dewatered for the inspection, and they only pretty much had two ways to do this inspection that they knew of at the time, and that was via manned helicopter or a roped access. One engineer would rope access every 5 to 10 meters down this canal, and they thought, they did their reviews on the helicopter, how it could get in there, how it could do it, and they found, well, on the left side of that photograph right there, the helicopter couldn't get low enough to do the inspection along that plinth slab. And so they said, okay, well, we'll move to the manned inspection where we'll just belay down every 5 to 10 meters. Well, they found with that it was going to take roughly 3 to 5 weeks to do the 4.5 kilometers, and they just thought, well, that's a lot of time. And then what if the gates on the canal, what if a malfunction happens and it fills? Well, we have a service worker down in the bight. That poses a major safety risk. So we actually struck the stars, because we went to this client and just kind of offered them this service, and they said, well, this is perfect. We have this pilot project that we could use you on right now. So they gave us this canal inspection, and we did it in 2 days. So what they were expecting to be about 4 weeks or a couple of helicopter flights, we were able to do and accomplish everything they needed in 2 days. So we were able to do eight flights each day, roughly about 30-40 minutes each flight. We were able to do HD video, and we were able to do high definition photos, and we were able to do a low pass that was really able to get down in the nitty gritty, just show any cracks, any corrosion that had happened from over the past 6 years. And then we were able to do a high pass where we were able to turn into like a 3D model for them, where they could geo-reference the location and see exactly where they were having problems. The deliverable consisted of a KMZ on Google Earth, and each point had a photograph, and they could click on it, see the reference. Again, they could rank the hot spots that needed to be repaired immediately, or those that they could wait till the next inspection happens in 5 years. So moving on to the next one. This is another really difficult to reach, hard to access location. This is about 2.25 mile inspection. That is the Pacific Ocean there. And it is from an uninhabited island there on the far side, from an inhabited island. So we were unable to get to the other side of the island, so they weren't able to do an inspection by ground. And they didn't want to send a buggy with service workers in it, because they didn't know the exact, how damaged the line was. It was an older line, so they didn't want it to break on them if they sent guys out on the line. So this one, again, we actually competed directly with a helicopter to see the different deliverables that we could perform or deliver, and see the quality of data that they received from both parties. So this was 1 day of flying. It was a long day. It could have taken, I would have probably done it in probably 2 or 3 days, because it was just they wanted very detailed inspection of it. So we went up, we did a pre-job inspection that was just 1 day. We rented a boat, we drove, or I guess we boated along the line, under the line, made sure where we'd be taking off. From Part 107, we were able to fly out of the boat, so we were able to fly from a moving boat. We worked with Transport Canada to do that. The height of the crossing in the middle was about 1,000 feet, and on that far end it was about 2,000 feet. So we were flying just within those limits of visual line of sight. When you're 2,000 feet up and you're 1,000 feet away, directionally wise, it can be very difficult to see your equipment, especially looking right up into the sun like we were that day. But we succeeded, and they, from the data that we collected, they were able to show that they needed to repair their line and replace it. So you can see there in the bottom right, those little pimples, and that's from about 30 feet off the line. So really quality data that can be gathered right now with UAVs with Part 107. And this last one here is one that I think Part 107 and the rules in Canada just really, if they were changed a little bit, it could have been accomplished a lot quicker and a lot easier. This is a 14-mile long transmission line that we had to do an inspection on, and it took about 2.5 days of flights. That 2.5 days of flights consisted of a lot of packing up the equipment, loading it up in the truck, loading up the ATV, driving a couple miles down to find a new access point, because there were just so many inaccessible sites. There was a lot of river crossings that, if we could have flown beyond visual line of sight, we probably could have shaved, a day off that operation time. The deliverable, again, it goes back to value of your company. It consisted of georeference photos, so each structure was referenced from the ground. Each photo was referenced, so they could go back in the future. When they look back at this inspection, they could say, okay, structure 304, the southwest corner, it had some wear and tear. Let's look at today's inspection and see exactly, okay, it's worse, we need to replace it. So we were able to give them a little bit of a data matrix with that for future inspections. Moving forward though, hopefully from the examples, these past 3 examples, and some of the key takeoffs that I think Part 107 will have, you can see that within the rules that Part 107 offers today, you can really use UAVs to your advantage, and you can really show clients or show your company that you can increase safety, you can save money, you can produce some awesome quality data with UAVs today, and that's within beyond visual line of sight, or within visual line of sight. But moving forward, it's still, we got to be able to fly over people. I answered the question earlier that a lot of our operations are urban, and if we can't fly over people, it really restricts our operations. And beyond visual line of sight, I know that might be a little bit of ways out, but if that can get opened up for more rural operations, I know that would really help increase the success of Part 107 and UAV usage. And that's all I have for today. I appreciate your time. Back to you, Demos.
Thank you very much, Ben. All right, so now that we've seen what kind of things you can do under Part 107, I guess the next thing we're going to do is talk about what's coming ahead. And with that, I'll hand it back to General Poss to tell us about the road ahead.
All right, thanks, Demos. Okay, so as we discussed before, Part 107 is kind of boring in and of itself, except for the one provision that allows you to waiver some pretty significant things. So here's what you're allowed to waiver. First and foremost, daylight, dawn, dusk operations, so where you can fly at night. This one should be pretty easy. We've done a lot of research on daylight versus nighttime visibility in Assure at the New Mexico State University, and unsurprisingly, you can actually see a drone better at night when it's well lit than during the daylight. Next one's interesting, and our Canadian friends have already brought this up. You can waiver operating from a moving vehicle or aircraft. I'll have to admit there's some valid reasons why you would want to fly from a moving vehicle, a boat, or a car. It does allow you to, if you can safely do it, keep your UAS flying within line of sight and then move around. Never been a big fan of operating a unmanned aircraft from a manned aircraft. We do it in the Air Force, but I've always thought that was unsafe, but there may be safe ways to do it. The next one is operation in a certain airspace. You're going to run into this no matter what you do. You're going to always be, possibly crossing into Class E airspace. Heck, maybe even Class C or B airspace, and that's what this is designed to do. So, for example, you're hired by Delta Airlines to do a photo shoot of one of their aircraft taxiing at Atlanta Hartsfield Airfield. This would allow this, although I don't think that's a good idea. Operating limitations, speed and altitude, you can waiver that, weight as well. That one is going to be a pretty linear one. If it's 500 feet, I don't think there's going to be a lot of problems with that. You want to fly at 18,000 feet, that may be different. One for the multiple UAS operations. This is a big deal with particularly the package delivery industry. If you're Amazon Prime Air, you're not going to be able to make money delivering packages under 5 pounds within 10 nautical miles of a Amazon distribution center if you have to have one remote pilot for each package delivery flight, but you can do it if he's controlling multiple ones. But the two really big ones that I'm going to go into detail that everybody's brought up before this are operations over people and visual line of sight aircraft operations. The fact that you have to keep your unmanned aerial vehicle within visual line of sight of the remote pilot at all times. These are really the two big ones that are impeding full utilization of commercial UAS in the United States. Okay, so first one, operations over people. I'm going to give the FAA an A+ on addressing this one. They've already assembled an industry group. They called it the Micro UAS Aviation Rulemaking Committee. I was the Assure representative to that. Really used a lot of the research that we had at the time from Assure to decide what to do for, first and foremost, micro UAS. In other words, that size and weight class of UAS that we're going to allow to not have any airworthiness whatsoever and fly over people because it's so small that it won't really hurt anybody or won't cause a serious industry injury if it falls on your head. But they also asked us to address other types of operations over people by heavier UAS that are flying under more risky profiles. And what we came up with was basically 4 categories of UAS operations. So the first one we've already discussed, that would be micro UAS. All you got to do is pull out a scale, and if it weighs less than 500 grams, you are a micro UAS and you can fly over people. No questions asked. The next one is actually pretty interesting, and Dave Arterburn at the University of Alabama in Huntsville is the sure lead for this. And what we're looking for are UAS that could be heavier but have a relatively low probability of injury. In other words, a very small chance is going to cause a fatal or a serious injury, about a 3% chance on that. And what we're finding from our research in ashore is it's depending on how the UAS is constructed and what flight profile it's in, you can get away with a fairly heavy UAS where the research isn't done and it's not releasable, but think 3 or 4 pounds might be possible there. So once we derive these industry standards for this, you can comply with the industry standards and you could be way up to say 4 pounds and then be allowed to fly over people. The next one we've kind of mentioned before, which is UAS enclosed work sites. This one will be where you would be closing down a movie set, or we talked about closing down a roadway to do this. This will also address transiting to and from your landing and takeoff site to the work site, and this one we've got a lot of experience with, should be pretty easy. The last one are UAS with mitigating measures and an approved hazardous operation. So, if you've ever seen a helicopter going into downtown Manhattan to put a cell phone tower on top of a skyscraper, that's a very large aircraft, say 2,000 pounds with another, 1,000-pound payload going down Manhattan. That man is flying with an approved hazardous operation plan. He's got special training. The local FAA FSDO has really looked at that with a fine-tooth comb and has allowed him to do that. Well, think about doing something similar with UAS. So this one could be, let's say CNN wants to come down to where I live and film Mardi Gras, and they want to bring a 30-pound drone. They could do that if they check with the local FSDO. They're going to operate it mainly over a hotel with a nice solid roof and not over people too much. And if they do go over people, they're going to have a parachute system that's going to deploy, and as long as they stay over 200 feet, they're going to be okay. So that's what they're thinking for operations over people. And the FAA has already got RTCA working it. They've appointed a committee to look at it, and they're looking to get industry-derived standards for review by the FAA and then research by FAA, NASA, and Assure to make sure they're safe and get that done in a relatively short period of time. So I'm very hopeful for operations over people. Beyond visual line of sight, we have got to have this, but it's a lot more complex than operations over people, and due to the complexity, the way ahead isn't as clear as operations over people. So why do we need it? Well, you need it to cover large areas. I'll give you an example showing the Mississippi Delta. You may be able to cover the California walnut crop, staying within visual line of sight very efficiently, just flying a couple miles away. You are not going to cover the cotton crop in the Mississippi Delta if you can only fly within visual line of sight. We've already mentioned linear infrastructure, power lines, pipelines. If you've got a pipeline that stretches from Canada to the United States, that's going to be tough to do if you've got to pick your UAS and throw it every couple of miles. Most maritime, if you're operating from a boat, if you're certainly operating from a shore-based facility, it's going to be tough to do that unless you fly beyond line of sight. And as a small boater in the Gulf of Mexico, I strongly support shore-based Coast Guard rescue drones that would operate under these rules. And the most important one, and one of our big lessons learned from the Air Force, was the truly expensive part of drones are not the vehicles themselves, and they're not really all the maintenance. It's how you handle the pilots and the air crew. It's how you handle the folks that interpret all the data. How do you store it? And it's very difficult to apply enterprise level information management or air crew resources if you're not flying beyond line of sight. And like I said before, the way ahead here isn't as clear as it is for ops over people. And let me give you just line of sight 101. The little circle in the middle in white is a very liberal visual line of sight. I'm going to say that you might be able to see your unmanned vehicle about 2 miles. Really, you're talking about 500 to 700 feet for most UAS, but let's be liberal and say 2 nautical miles. Now, for a drone, if you're on the ground and you're flying your drone at 400 feet, the radio line of sight is where you can maintain that data link is about 28 nautical miles, so that's pretty big. So what does that mean in a realistic target like the Mississippi Delta? So if you're going to go after the cotton crop in the Mississippi Delta, you can do that with 9 or 10 radio line of sight systems. So you got a data link in the middle of each one of those green circles. You can do that with let's say 10 of them. If you're going to go with just visual line of sight, even with my very liberal 2 nautical miles, that's about 100 different sorties that you've got to cover that. It's just not going to happen. Now, if you go beyond line of sight, you can base that drone in Pennsylvania and fly it down once a week to cover Mississippi and do that very economically. So what's technical problem number one? Technical problem number one is how do you maintain a constant, reliable link with your UAS? If you're the United States Air Force and you can afford to buy entire Ku-band transponders for your drones, it's pretty easy, and that's how we do it in the Air Force. So we'll launch a drone from Afghanistan using conventional line of sight data links. It gets up to a certain altitude. We flip a switch, turn it over to a Ku-band satellite in geosynchronous orbit that hits somewhere in the hemisphere, and then we essentially fiber it out to anywhere on Earth. So that way you can control the drone from Las Vegas, Nevada, 6,000 miles away with relatively low latency. But that's very expensive, and it's not a realistic solution for most of our commercial providers. However, there is another way to do it, and that's the way we also do it in Afghanistan. We used ground relay links, and in this case I'm showing you a simple mesh network that's in this case using Wi-Fi, but we normally use military frequencies for that. And basically what we do for some of our missions, we'll take off, we'll fly with a radio line of sight link from an airfield in Kandahar, and we've got to go across the country, and the aircraft is going and it's switching essentially from cell phone tower to cell phone tower, just like you would with your phone. But in this case, it's using a mesh network to do that. That makes it much more affordable. The problem with this is making sure that it's as reliable as other types of data links, so the FAA will approve your waiver. And the big problem is real estate, location. Cell phone companies have got all of the great locations with cell phone towers on already, and then the really big problem is spectrum. If there's spectrum available out there, mainly the wireless industry's already bought it, so if we're going to do a real beyond line of sight reliable link system, I guarantee you it's going to involve cooperate with cell phone companies. The next big problem we got is detect and avoid, and here's our snazzy Assure graphic. We're researching that with the University of North Dakota, generally doing airborne sense and avoid, and New Mexico State University generally doing ground-based sense and avoid. And you're going to have reliable long-range data links, like I mentioned before, that will enable you to do stuff with ground-based sense and avoid, but you're also going to have airborne sense and avoid links, because you'll never be able to be completely linked up at all times, and you've got to give the aircraft an ability to avoid threats on its own. So what do I mean by that? Well, the reason why we've got this nice drone revolution graphic there, and you have the CEO of Intel Corp, and he is in charge of the new Drone Advisory Council, is because Intel has made a breakthrough on airborne sense and avoid. And here's their new system. Here's kind of a breadboard system. If it kind of looks familiar, it's got sonar sensors and then some electro-optical infrared sensors there. It's essentially their old Kix, Connects controller that allowed you to gesture in front of your TV for your Xbox. They've adapted it for UAS, and it works pretty daggum well. And that may be a solution for short-range airborne detect and avoid. There's a whole bunch of other systems out there, and we can talk about them. General Atomics has got a great airborne system that relies on radar, but airborne detect and avoid is always got to be part of the solution because you can't be completely reliant on the next thing I'll talk about, which is ground-based sense and avoid. So ground-based sense and avoid is actually a pretty smart one, and the theory is if your drone isn't big enough to put a giant 360-degree, very fine-grained radar on board it, don't. Leave the radar on the ground, and then as long as you're talking to a data link, via data link, you can use the ground radar to talk to the ground control system and the remote pilot, and he can keep the UAS out of trouble against non-cooperative targets. One thing I did forget to mention is I would, if you're going to be flying beyond line of sight, I would almost guarantee you that the FAA at a minimum is going to make you have ADS-B on board, just like all manned aircraft are required to have ADS-B here in the future. ADS-B is pretty much a complete solution against cooperative targets, other aircraft with ADS-B. But the problem that you've always got to address with your airborne sense and avoid, in this case your ground-based sense and avoid, is those non-cooperative targets. That guy that has got a broken ADS-B, didn't want to put it in there, balloons, flocks of birds and whatnot. So under the ground-based sense and avoid, you just put, for example, an L-star radar up, which has got great range resolution, will shoot out about, on a good day, 8 to 10 nautical miles. It helps you avoid non-cooperative targets. You wrap that in with NASA's Unmanned Traffic Management System, which is a great system and is probably worth an entire webinar to talk about that as well. And you've got a way that for a subscription-based service, you pay so much per month to sign up for the service, and it'll stop you from running into non-cooperative targets as long as your data link is working. And then, of course, if it's not working, you've got your ADS-B on board, and you've got your airborne sense and avoid on board, and you are probably an order of magnitude safer than most general aviation aircraft when you are in that point. So, long talk, but two main points. We got to solve operations over people. We're doing well on that, and then we've got to solve beyond line of sight. We're not doing as well, but not for lack of trying. It's just a very difficult technical problem. And Demos, that's all I've got, so I'm going to turn it back over to you. Thank you.
Thank you very much, General Poss. All right, so before we move on to the last Q&A, two things. One, actually a couple of things. One, audience, please keep on sending in your questions. We'll try to address them at the Q&A coming up shortly. Secondly, please visit the Inside Unmanned Systems website. Address given here for the presentation will be there, I guess, sometime down the road. And then contact info for our panelists is here, so if you want to directly get to them and ask questions, you have contact infos here. Next, we will do a final closing poll here. And Lori, if you could bring that poll up.
Sure. On the screen here, our final poll, now that FAR Part 107 is here, my organization will probably, and in this case we're looking for one response, start purchasing a small UAS for our work, start operating a small UAS we already have, start contracting the services of small UAS provider, start evaluating whether to use small UAS or for aspects of Part 107. And there we have our responses. Looks like 18% start purchasing small UAS for work, 30% start operating a small UAS we already have, 5% start contracting the services of small UAS provider, 30% start evaluating whether to use small UAS, and 17% apply for a waiver. Pass back to you, Demos.
All right. Thank you, Lori. All right. Let's get to the, I guess, final Q&A session here, and thanks for the questions that are coming in. Keep them coming in. So the first question I'm going to pose here is for Ben, and it's a question about it's about the question about how can you use UAV, for example, to do dam monitoring. Have you done that type of an application before? Has someone asked for it, or how would you go about doing it?
Yeah, absolutely. A few of our clients have asked for, especially on the dam safety side, this will be for visual inspections. Sometimes when they dewater dam head gates, we can go in and do kind of a visual inspection. You can do a 3D model of a dam face. We've never been asked to do that, provide that, but usually what we'll go in and do is just provide a visual inspection of concrete, any corrosion, any cracks that are happening in the concrete. So yeah, it can be done. It's been being used quite a bit.
Right. All right. Next question is for General Poss. What was the recent court case you mentioned that allowed the FAA to enforce, have the authority below 500 feet? Is that something you'd comment on, or?
Yeah, I don't remember the case. I think it was I know the company was Skypan, S-K-Y, next word P-A-N, and I think it was Skypan versus U.S. or something. But basically their argument was the FAA has never regulated below 500 feet, and if you looked at older aviation charts, it kind of has a big thing saying, flying under 500 feet and various types of airspace, you do so at your own risk. And they were, Skypan was going to get a substantial fine from the FAA, and they took them to court, and generally the court agreed that no, the airspace, all airspace is governed by the FAA. It's just that they weren't, happening to closely control that below 500 feet. Now, I'm not a lawyer. I'm a non-attorney spokesperson. There's an additional complication, and I don't have a good answer on it for you, and I don't think even the FAA lawyers would. There is a bubble somewhere below 0 feet, and maybe 100 feet or so that the courts still need to rule on, and the unique nature of drones makes that a little bit more complicated, because there have been cases against the Air Force for flying too low, frightening cattle, and successfully sued them, and at the time, I believe, don't quote me on this, I believe that the limit was 100 foot. So there is a little bit of wiggle room on that, but that wiggle room is between the FAA and local authorities as to over how high you can fly. So, but I'm sure there's plenty of lawyers on the webinar here that can answer that question better than I can.
Thank you, General Poss. Next question. This one is for you, Mike. And after you, Mike, Ben, if you want to jump in, you could say something about it. But can you comment on, I guess, some of the software capabilities, et cetera, out there that enable the type of, what's the current state of them, that allow the type of UAS operation that your customers are interested in?
Yeah,
kind of
I think it.
General question.
Yeah.
Go ahead.
Yeah, I think it depends on the phase of the operation that you're looking at. But if you look at the planning portion of it, the mission planning, definitely the software is out there. There's different variants of it, and it's improving, I guess, depending on the manufacturer. I think when you look at the process of the data, this is where it kind of gets interesting. Depending upon the market, you see the development, definitely in the mapping, and I include in there also the precision ag, because it is a big mapping. We see a lot of softwares being generated, and it's specifically for UAV type applications. It's a little bit different than maybe the traditional airplane, manned air aviation from the mapping perspective. So we're starting to see that really come out, but they're also adapting a lot of the capabilities to process the data. We talk about direct georeferencing. There's RTK out there, PPK, so we're starting to see it, that you can actually use it. I think the one that really needs to be developed more, and we'll start to see it, is actually kind of getting in the industrial inspection and maybe automating some of those pieces a lot more. It's maybe one of the things that we're definitely looking at, interested in from there.
Thanks, Mike. Ben, anything you want to add to that?
I think Mike hit it on the head there.
All right, excellent. Next question. This one is for you, General Poss. It's, do you think the sense and avoid problem will be approached by requiring additional training or systems on manned aircraft as well as the well, primarily on the manned aircraft, or how do you see that going?
That's a very good question, and that's kind of the the dirty secret of aviation, is that we spend a lot of time concentrating on what we need to do to drones to make them safer so they don't run into manned aircraft, and a lot of time on airworthiness for drones and all that. We don't spend near enough time on making manned aviation safer. And when I'm talking manned aviation, I'm mainly talking general aviation aircraft, because our airliners and military aircraft are pretty safe, although there are quite a few military aircraft that are not fully compliant with the new NAV standards. I think you have to address it holistically. And matter of fact, one of the things, and we can possibly talk about it at another webinar, one of the concepts we're talking about is coming up with a bubble of airspace that's going to be managed by unmanned traffic management systems, and inside that bubble it'll be covered by ground-based sense and avoid radar and this data link that we've got to develop in a new computerized system for managing the air traffic. And one of the things the FAA is thinking about is, wow, do we keep manned aircraft out of that bubble? If we allow manned aircraft in, do they have to have similar equipment to what the drones have? So as an absolute minimum, you've got to have ADS-B. You probably don't need 360 automatic detect and avoid like the drones may have to have, but it's a valid question. One of our frustrations in the aviation community is, for a variety of reasons, we haven't been more aggressive than a lot of us think we should be in requiring all aircraft to have ADS-B as a minimum. And there's a variety of reasons for that, but if you're looking at safety records of aircraft equipped with ADS-B versus those that aren't, and near misses and hatters and all that filed, it's a lot lower for aircraft that have proper modern safe navigation equipment like ADS-B than it is other aircraft. Yet that kind of puts us in an interesting situation to where if we do all of our math right with drones, they can end up being an order of magnitude safer than manned aircraft, because manned aircraft, the final thing they rely on is their ability to see and avoid. But gosh, I'll tell you, it's tough to see and avoid when you're really only looking out the front of the aircraft. You really can't look down because the nose of the aircraft is there. It's tough to look up. And you're looking at objects that are coming at you maybe with a closure speed of 1,000 knots. That's tough to ask a human to do that, but it's a solvable technical problem, and we're going to make the drones solve it. The question is, should we make the manned aircraft solve it? And I think my answer would be yes.
All right. Thank you. Next question I'll pitch it at you, Mike, first, and then I'll probably see if Ben has something to add to it. Is, can you say something about, I guess, requests or operations that you need to do from moving vehicles, operating the small UAS from moving vehicles? And I guess.
Yeah, for sure. I think that it's I'll go back to one of the key points I like, and it's kind of conducting flight operations and airmanship. And what we've seen. Mostly our experience has been with boats. Maybe Ben could comment on vehicles, but to me, there's a few aspects in operating from boats. Number one is there's sensors on board aircraft, or on board the UAVs, that could get affected by the structure itself. So if it's a metal structure, it could, for example, affect the mag. So you got to work around that. So we always recommend is to conduct test flights on when you're alongside before you actually have to go in the water. The other complication that gets into water operations is that if you have to respond to emergencies, you may not have the same options when it comes to landing your system. So having those processes down and understanding that is very important in it. So there's a lot of this, and it always comes back to, I always say to people, if you're thinking about it the first time during flight, it's too late. All this has to go into your mission planning and preparation to make sure you look at every consequence that could happen during that operation. And maybe Ben can comment more based on his experience.
Yeah, I really think it dramatically it expands the areas that you can use a UAV. It really opens up the amount of ground you can cover in a flight. A lot of times we've operated from a moving vehicle. it'll be, you know, sometimes when we do distribution in a rural area, we'll fly from a truck, because that just, it expedites the process of flying, you know, walking from pole to pole if you're doing an inspection. A lot of the moving vehicle, you know, we do not operate fixed wing aircraft, so, you know, we're only flying about, you know, max 8-10 meters a second when we're flying from pole to pole, so it's quite controlled. So we do still have the ability to, you know, manually take control of the aircraft if anything goes haywire. With that being said, we're flying manually, so it would be great if UAVs, and I know the sensors are really improving, where they could sense and avoid the kind of the contours of the ground, or, you know, obstacles and terrain. So if, you know, you're doing a right-of-way inspection and you got to be within line of sight, you can just, you know, drive under the equipment, and it's on autopilot, and it'll just, you know, take a picture every, you know, meter or 2 meters of the right-of-way. Well, that'd be great, but right now we do fly manually, so we haven't had too many problems from operating from a vehicle. With the boat, Mike did hit on, we did have some frequency interference with the mag, where the equipment, you know, it would go a little haywire when we take off because we were flying from an aluminum boat, but we knew that going in, so we took the necessary precautions. So like Mike said, you got to know before you go.
All right, a lot more questions than we have time to answer, and a lot of good ones here that I would have loved to address, but I guess we can't. We're running out of time. So thank you very much to our panelists, and with that, I think I'm going to hand it over to Lori to close the webinar.
Yes, it's time to wrap, but first just a few closing remarks from Mike Dziak of Microdrones. Over to you, Mike.
All right, thanks, Lori. And on behalf of Microdrones, I just want to say thank you, first of all, to everyone who joined us today, also to our panelists, General Posh from ISR Ideas, Mike Hogan from Microdrones, Ben Van Leer from Raycon, as well as DeMose, Richard Fisher, and the team from Inside Unmanned Systems. I think there was a lot of information here, very inspiring. I have a lot of ideas, and I'm sure that you do too. I think it's great that there's a lot of questions that were answered, but also some remaining ones. So I invite you, there will be a email that goes out following this webinar, and we'd certainly like to make ourselves available to help you get answers to those questions if they weren't answered on the call today. So I know that my email address will be in there. You can send those my way, and I'll see that they get to the right person to give you very good answers. So again, thank you all, and really wish you the best in all of your efforts in the coming year. I'll turn it back to you, Lori.
Okay, and as well, special thanks to General Poss, Mike Hogan, and Ben Levere, our speakers for today, and as well our sponsors and co-hosts Inside Unmanned Systems and Microdrones. Again, thanks for joining. This is Lori Dearman saying, hope we see you on the next one. Bye for now.